Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0223 indicates a high voltage condition within the Throttle Position Sensor B circuit. This particular error signifies that the voltage reading from the throttle position sensor exceeds the normal operating range, which can lead to performance issues in the engine's throttle control system. The Throttle Position Sensor, TPS, is crucial for determining the position of the throttle plate in relation to engine demands. It typically resides in the throttle body, which is situated between the air intake and the intake manifold. The throttle body houses the TPS, which sends voltage signals to the Engine Control Module, ECM, or Powertrain Control Module, PCM, for optimal air-fuel ratio adjustments and engine performance. Understanding the role of these components is essential for pinpointing the cause of this error code and ensuring vehicle functionality. DTC P0223 indicates that the Throttle Position Sensor B circuit is experiencing high voltage. The Throttle Position Sensor B, which receives voltage from the ECM/PCM, is responsible for detecting the throttle plate's angle and position in the throttle body. Its function is critical to facilitate proper air intake for optimal engine performance, making it a vital component of the drive-by-wire system used in modern Honda vehicles. Located in the throttle body assembly, the TPS is typically connected to the ECM/PCM via a wiring harness. If the sensor transmits a voltage that exceeds approximately 4.8 volts, it triggers this specific DTC. Being informed about the sensor's location and functionality helps in accurately troubleshooting issues related to this error code. Several potential causes may lead to the activation of DTC P0223. One of the most common reasons is a poor electrical connection at the throttle body, which may disrupt the signal being transmitted between the TPS and the ECM/PCM. Loose terminals at the ECM/PCM can also contribute to this issue, as they may create intermittent connections that can confuse the control module. Moreover, internal faults within the throttle position sensor itself could lead to incorrect voltage readings, triggering this fault code. Each of these causes needs to be systematically examined to prevent misdiagnosis. Having clear knowledge of what causes DTC P0223 allows technicians to perform a focused investigation. When DTC P0223 is present, drivers may experience a range of symptoms. A common manifestation is poor throttle response, where the vehicle may not accelerate smoothly, causing delay in power delivery from the engine. This can lead to overall decreased engine performance, particularly during acceleration or when trying to maintain speed. Additionally, the check engine light will illuminate on the dashboard, serving as an alert that the vehicle's onboard diagnostics have detected an issue. If left unresolved, these symptoms can result in a less than optimal driving experience, and vehicle reliability may be compromised. Understanding these symptoms is crucial for timely intervention. The first step in troubleshooting DTC P0223 involves turning the ignition switch to the on/to position. This action is crucial as it activates the vehicle's electrical systems and enables the diagnostic tool to communicate with the vehicle's onboard electronics. Additionally, it's important to record all freeze data captured by the onboard diagnostics, as this data provides historical context about the fault occurrence, aiding in further analysis. Reviewing the general troubleshooting information is also recommended to ensure that all potential avenues are considered before proceeding. This foundational step is vital for a systematic and efficient troubleshooting approach. After turning the ignition to the on position, the next step requires clearing the DTC using the Honda Diagnostic System HDS. The HDS is an essential tool that allows technicians to interface with the vehicle's engine control module to reset any fault codes that may be actively stored. Clearing the DTC ensures a clean slate for monitoring new data, making it easier to diagnose if the issue returns. Following this, the technician must prepare to check the Throttle Position Sensor B data in the next steps. This essential step helps in distinguishing whether the fault is persistent or an isolated incident. In the third step, the HDS should be used to check the Throttle Position Sensor B, TP Sensor B readings directly from the data list. This allows technicians to assess if the voltage from the sensor is about 4.8 volts or higher, which indicates normal operation. If the readings show a voltage equal to or exceeding this threshold, it suggests that the circuit might still be functional and not the source of the trouble code. Alternatively, if it registers lower than this value, it may point towards an intermittent failure or issues such as poor electrical connections. This analysis of actual sensor data is critical for accurate diagnosis and next steps. The fourth step in the troubleshooting process requires checking the HDS for any pending or confirmed DTCs. It's essential to ascertain if DTC P0123 is present alongside P0223, as the simultaneous existence of these codes can indicate a specific underlying issue. If both DTCs are present, it prompts the technician to follow a different diagnostic path, Step 13. If only P0223 is indicated, the technician can then proceed to the next troubleshooting steps. This step is vital in determining if multiple sensor issues exist or if the problem is isolated to the sensor in question. In this step, the technician must turn the ignition switch to the lock 0 position. This action is essential for ensuring safety while working on electrical components. Disconnecting the vehicle's power supply minimizes the risk of electrical shock and further malfunctions. After the ignition is securely off, the technician will prepare to disconnect the throttle body 6P connector. Ensuring the ignition is off at this stage allows for a clearer understanding of the wiring and electrical relationships without active power interference. Safety should always be a priority during vehicle service to prevent accidents. Now that the ignition is turned to lock 0, the technician should proceed to disconnect the throttle body 6P connector. The 6P connector is an important interface that carries signals related to the Throttle Position Sensor B. By carefully removing the connector, the technician will expose the terminal pins necessary for subsequent voltage measurements. This step is crucial in isolating the TPS from the rest of the circuit, which helps to determine if the sensor itself is failing or if the fault lies elsewhere in the electronic control system. Precision in disconnecting connectors is vital to avoid any damage to the components. After disconnecting the throttle body 6P connector, the technician should turn the ignition switch back to the on position. This action powers the vehicle's electrical systems again, allowing the diagnostic tool to perform voltage testing on the TPS-B circuit. By ensuring the ignition is in this state, voltage readings can be accurately captured at the 6P connector without interference. This step prepares the technician for the next critical measurement, testing for voltage between throttle body terminal number 3 and body ground. Ensuring meticulous following of the process is essential for precise diagnostic results. In this step, the technician will measure the voltage at terminal number 3 of the throttle body 6P connector while ensuring the vehicle is powered. The voltage should ideally be around 5 volts to indicate a properly functioning throttle position sensor B circuit. By comparing this reading to body ground, the technician can ascertain if the sensor has adequate supply voltage, which is critical for its operation. If the reading aligns with the expected 5 volts, the next step can be undertaken. Conversely, If it indicates a voltage significantly lower than this, further investigation into the wiring and connections is warranted. Understanding the significance of these voltage readings is crucial for identifying faults quickly. Following the voltage measurement, the technician must turn the ignition switch to the lock position once more. This safety measure is essential before making any further connections or disconnections to prevent unintentional short circuits or damage. After ensuring the ignition is off, the technician should jump the SCS line with the HDS tool. The SCS line, or Service Check System line, allows technicians to watch for other potential faults that may not be identified on initial testing. A thorough approach ensures that every aspect of the circuit is investigated properly, creating a competent diagnostic environment. In Step 10, the technician will disconnect the ECM-PCM connector C, which contains 49 pins. This action facilitates access to the internal circuits of the Engine Control Module, ECM, or Powertrain Control Module, PCM. Proper handling is crucial during this step to avoid any damage to the delicate electronic pins and connectors. Disconnecting the ECM-PCM enables further testing and checks for continuity, critical in verifying the integrity of the connections leading to the Throttle Position Sensor B. These careful procedures allow technicians to ensure they are isolating the issue effectively. In this crucial troubleshooting step, the technician will check for continuity between the ECM-PCM connector terminal C21 and the throttle body 6P connector terminal number 3. Using a multimeter, continuity testing verifies whether an uninterrupted signal exists between these 2 points. In a properly functioning circuit, there should be clear continuity, indicating that there are no breaks or shorts in the wiring. If continuity is confirmed, this suggests that the wiring is intact, and the issue likely resides with the throttle position sensor itself. However, if continuity fails, this indicates a potential wiring fault that requires further inspection and repair. Final repair verification for DTC P0223 entails a systematic check to ensure that all required repairs have been effectively completed. After addressing the identified issues, the technician should utilize the HDS again to see if any recurring DTCs appear. If DTC P0223 is still present, further investigation is necessary to determine if the original issue remains unresolved. Post-repair, conducting a test drive in various conditions facilitates the verification of repairs, checking if any fault symptoms, like poor throttle response, recur. This comprehensive approach ensures a well-rounded outcome and helps maintain customer satisfaction in vehicle operation. For ongoing preventive maintenance in relation to DTC P0223, periodic inspections of the throttle body connections are recommended. Ensuring that all electrical contacts are clean and free from corrosion will aid in maintaining an optimal connection for the sensors. Regular checks on the throttle position sensors can help identify any early irregularities before they lead to error codes. Implementing a routine maintenance schedule can significantly reduce the chances of DTC activation in the future and enhance overall vehicle reliability. Keeping electrical connections secure and maintaining sensor integrity contributes to effective engine performance and longevity. In conclusion, dealing with DTC P0223 requires an organized approach aimed at identifying and resolving voltage issues within the Throttle Position Sensor B circuit. By following each step methodically, technicians can accurately diagnose the underlying causes of the error code and implement necessary repairs. Recognizing the significance of all related components and connections leads to effective outcomes. Additionally, routine vehicle maintenance plays a pivotal role in preventing these types of error codes from arising in the first place. Empowering vehicle owners with knowledge about the importance of maintenance allows for prolonged vehicle health, safety, and performance. Please like and subscribe to the channel. See you next time.